Golden Iris Production presents From Coulomb to Emergent Gravity, a stepwise derivation to G equals Planck length squared times C cubed over h bar, by Mark F. Dennis. Abstract. In this presentation, we develop a compact and internally consistent derivation linking electromagnetism to gravity. We begin with a Coulomb-like formulation and systematically transform it using vacuum identities and the fine structure constant. Along the way, we introduce a fundamental length scale, referred to as the preon radius, and show that it is not arbitrary but exactly related to the Planck length through the fine structure constant. The result is a direct bridge between electromagnetic structure and gravitational coupling at ultra-short distances.
Why preons? The preon hypothesis proposes that quarks and leptons are not fundamental, but instead composed of deeper constituents. Historically, models such as the Rishon framework attempted to reduce the number of fundamental particles and explain charge quantization and family structure. While no experimental evidence currently supports compositeness below about 10 to the minus 19 meters, preons remain a useful conceptual tool. They allow us to explore how known constants might organize physics at scales approaching the Planck length. Reissner-Nordström scale. In general relativity, a charged mass is described by the Reissner-Nordström solution. The metric includes a charge-dependent term that introduces a natural curvature length. This length is defined as r sub q squared equals g times q squared over 4 pi epsilon 0 c to the fourth. Using standard electromagnetic identities, this simplifies exactly to the Planck length times the square root of the fine structure constant. Numerically, this gives approximately 1.38 times 10 to the minus 36 meters. This is not a measured particle radius, but a theoretical scale where electromagnetism and gravity intersect. Step 1. Emergent gravity form. We begin by defining a fundamental scale R0 using a Coulomb-inspired structure. From this definition, we solve for G and obtain a new expression. G equals 4 pi c squared r0 squared divided by mu0 q squared. This mirrors the structure of Coulomb's law and suggests that gravity can be parameterized using electromagnetic quantities and a fundamental length.
Step 2. Vacuum recasting. Next, we use the identity that c squared equals 1 over epsilon 0 mu 0. Substituting this into our expression for G gives G equals 4 pi r0 squared divided by epsilon 0 mu 0 squared q squared. This makes the role of the vacuum explicit. Gravity now appears directly tied to the electromagnetic properties of empty space. Step 3. Numerical scale. Using known physical constants, we evaluate R0 numerically. The result is approximately 1.38 times 10 to the minus 36 meters. This places the scale just below the Planck length. Step 4. Exact identity. We now introduce two key definitions: the fine structure constant and the Planck length. Combining these with our earlier expression leads to an exact identity. R0 squared equals Planck length squared times alpha. So R0 equals the Planck length times the square root of alpha. This shows that the preon scale is fixed entirely by known constants.
Step 5. Recovering Planck gravity. Substituting this identity back into our equations, the fine structure constant cancels cleanly. What remains is g equals Planck length squared times c cubed over h bar. This is the standard Planck expression for gravity. So the emergent formulation is not new physics, it is fully consistent with known physics, but derived from a different starting point. Dimensional checks. We verify that all expressions are dimensionally consistent. The vacuum identity gives the correct units for velocity. The preon radius has units of length, and the Planck expression reproduces the correct units for the gravitational constant.
Summary. We began with a Coulomb-like structure and derived an emergent expression for G. Rewriting it in terms of vacuum constants revealed the deep role of electromagnetic structure. We computed the preon radius and showed it lies just below the Planck length. We then established the exact identity relating it to the Planck scale through the fine structure constant. Eliminating alpha recovers the standard Planck expression for gravity. This confirms the internal consistency of the entire derivation. The key physical insight is that gravity can be expressed either in terms of Planck units or in terms of electromagnetic quantities plus a fundamental length scale. The relation R0 equals Planck length times square root alpha connects these two views. If substructure exists at this scale, its size is not arbitrary. It is fixed by universal constants. This suggests that gravity may emerge, at least conceptually, from electromagnetic vacuum structure interacting with an ultrashort length scale.
Rn radius revisited. Returning to general relativity, the Reissner-Nordström solution defines a charge-based curvature scale. This scale is identical to the one we derived. Exact identity again. Using known electromagnetic identities, we again find R sub q equals Planck length times square root alpha. Numerical value. This gives a value of approximately 1.38 times 10 to the minus 36 meters. Scale hierarchy. Comparing physical scales. The classical electron radius and Compton wavelength are much larger. The Schwarzschild radius is vastly smaller. But the Rn radius and the preon scale coincide. This is the key alignment. Rn horizons. For an electron, the gravitational term is far too small to form a horizon. The classical solution predicts no black hole, only a naked singularity. Sanity checks. Units and identities confirm the correctness of the derivation.
Sanity checks. Units and identities confirm the correctness of the derivation. Connection to preon scale. The preon radius and the Rn curvature radius are exactly the same quantity. This is a central result. Classical versus quantum radius. The classical electron radius emerges from electromagnetic self-energy. A quantum analog using gravitational structure reproduces the same scale. Circumference comparison. Comparing circumferences shows the enormous gap between classical and preon scales. The preon circumference is many orders of magnitude smaller. Final insight. At the deepest level, this work suggests a structural unity. Electromagnetism, quantum constants, and gravity all encode the same fundamental length hierarchy.
References slide. Key references include standard texts in general relativity and electrodynamics, including works by Misner, Thorne, Wheeler, Carroll, Wald, and Jackson.